This is The Future Of, where experts share their vision of the future and how their work is helping shape it for the better. It's been half a century since humans travelled to the moon, when astronauts explored an area of the moon known as the Taurus-Littrow Valley in 1972. Now, NASA's Artemis space program could resume travel to the moon by 2024 and provide exciting opportunities for the next generation of planetary scientists and space explorers. To explore this topic, I was joined by Professor Phil Bland and Professor Gretchen Benedicts. Phil and Gretchen are both planetary scientists from the Space Science and Technology Centre at Curtin University. We talked about NASA's Artemis program, how Curtin University is involved, and the evolution of CubeSats and lunar mining. If you'd like to find out more about this mission and the research in planetary science, visit the links provided in the show notes. Gretchen, let's start with you. Tell us about NASA's Artemis program. How will it contribute to our understanding of the moon's geology and history?
So it's really, I think it's really important, and it's really good that this program has been created to go back and answer some of these science questions, but there's also this whole idea of how it's going to open up other areas of, like, what can we do in space? Not, we want to know the history because that helps us understand a whole bunch of kind of basic science questions, but all those basic science questions lead to things that we do here on Earth.
And what about those big questions? What are some of the questions that they hope the Artemis program will answer?
We understand how the moon formed. We have a good sense of like the formation theory. And part of what the astronauts did when they went to the moon before was to try and gather evidence that would help that work.
You can kind of think of it from the point of view of, so Apollo, in total, I think they were probably there for 7 or 8 days, right? Something like that. Artemis, it's actually really hard to get your head around just what an incredible change that's going to be. And, you're going to have like 4 or 5 big missions every year between what NASA is doing and what all the private sector contractors are going to be doing. Loads of landers, loads of places, just so much more information. It's going to be incredible. And I think, the main difference is that in the Apollo missions, it was you could kind of think of it as sort of a scouting.
Yeah, reconnaissance.
Yeah, reconnaissance. And so you can get the kind of broad brush idea of sort of, how the moon formed. But that's like having the broad brush idea of how old Australia is, right? Whereas you kind of want a bit more detail.
You go into those areas, and geologists are very much, let's go to the field. We can get some information if we go to the field. And so in space geology, we spend a lot of time remote sensing and getting very good and accurate information. But as a geologist, you're always kind of angling for that. I want to know where that rock actually came from. If I can't actually hold the rock, then I want to go get it. Or if I have the rock, I want to know where did it actually come from, because then you can make the case of understanding how this process might have moved things around or concentrated elements that might be really interesting to look for, or change how we think about the things that we use here on Earth and how we might use them in space.
And I think that's it's like, when we first went to the moon, and for several decades afterwards, we kind of had this idea of the moon as pretty much a dead object. And, it's not geologically active now, but we now know that its geological history has been much more interesting than we thought back then. And, there's kind of water been involved in how it's evolved over time. So, there could be an awful lot more going on there than we ever thought, which is like super exciting.
The other thing is that we've looked at the surface. We've walked on the surface. We've had a tiny bit of information about what's going on underneath the surface. But we know that on Earth, a lot of the system works because there's interior stuff happening that creates all kinds of stuff that occurs on the surface. And even though, geologically speaking, the moon is pretty quiet, understanding what's going on in the interior would be really useful to really unravel its formation, because it's got some really bizarre features.
So a chance to gather a lot more information, but also a lot more context, right?
Absolutely.
Yep.
So what are some of the key stages, and this can go to either of you, what are some of the key stages of the Artemis program?
I mean, so I think it was really exciting just a couple of days ago when NASA picked the team for the next mission, and that's going to be amazing. It's the first orbit of the moon, first mission to go around the moon was Apollo 8 and in 68. And I always think that was kind of the most bold mission, to be honest, out of all of them, because I think I've got a thing in my head that they decided to do that in a month. And so Apollo 8 was going to be an Earth orbit test. they thought, actually, no, Russia might beat us to an orbit, and let's. So I think that was a time when people did bold stuff, just off the cuff, which is just amazing. And I think and since 72. Which was Apollo 17, a lot of people don't realize that, humans have only been 400 kilometers away from the Earth, right? Which is kind of like here to Geraldton or something.
How far away is the moon?
Yeah, 400,000. So it's so these folks on Artemis 2, they're going to be going 1,000 times further away than people have been in 50 years, which is, they're only going, it's a 10-day mission, but that's quite a lot of pressure. So I think, that's awesome.
It is. And after this next one, they kind of scaffold everything together. So this one is kind of like Apollo 8, where it was, we'll just go and we'll just figure out what's going on in orbit around the moon. And then the next mission builds on what they learned from that one. So then Apollo 3 is in the pipeline. It will take what we learned Artemis. Artemis 3 will take what we learned from Artemis 2, and then Artemis 4 will build on all of that. And so there's a whole nice idea of, we build up our knowledge and we do things in a very safe manner, but we build up our knowledge so that we can do it in a really good way once we get there.
When we're talking about that scaffolding of knowledge and collection of information, I'd love to know, what role will Curtin play in the Artemis program? What does that look like, Phil?
Yeah, I mean, so it's what we've been kind of working on is, and working with colleagues in the US as well, are concepts for missions, and one mission in particular that can help Artemis and Australia's engagement with Artemis in the Australian Space Agency's Moon to Mars program, in trying to, kind of doing a resource prospecting orbiting mission. And I'm like, so we've got a team that is working on this right now. I'm just super excited to see, where we go, but basically it's the kind of thing that if you're a mineral exploration company on Earth, then you do a geophysical survey of, that area that you're interested in. There's one kind of component of that for the moon that is just really not known very well. So, and that's a magnetic survey. So kind of the, how the the magnetic intensity varies over an area, and that can tell you, an awful lot about the geology of it. Are there ore deposits there? It's basic information in terms of understanding the geology of an area, and it's really not. The previous stuff from previous missions is really poor resolution, and so we think we can get very, very good resolution by basically flying spacecraft at bonkers low altitude to do that survey. And by bonkers low altitude,
we're being bold.
We're being bold. Exactly. So it will be. It'll average about 18 kilometers above the surface, but we might get down to just a few kilometers like above peaks. So it's kind of like airliner kind of altitude. So it's sort of more a kind of a drone situation.
You're going to be like a TIE fighter or a X-Wing flying into the Death Star, aiming for that,
No, it's much more organized. Okay, so much more organized.
Of course
yes,
it is.
okay, so it will be like that.
But it will be a little bit like that. It's just a much smaller little spacecraft.
That's true.
Permission to have a little bit of fun.
I guess.
surely.
Oh yeah, absolutely. I mean, from my point of view, it's going to be an awful lot of fun.
Within the confines of safety and mission, mission plan and
from the engineers
goals.
and the operations team, much less fun, much more scary. But from my point of view, yeah, a lot of fun. Yeah.
And now, what about the CubeSats? CubeSats, yeah.
CubeSats, yeah, and that's kind of the sort of the integral part of this program. So Curtin, we flew. So these are a satellite that is built around a 10 by 10 by 10 centimeter form factor. That was developed really as kind of just a standard, so that you didn't have to keep having bespoke deployment mechanisms on the top of rockets, right? So if everything is a fixed form factor, I'm using my hands to describe this, which is obviously pointless, then if everything's a fixed form factor, then you can have fixed deployment mechanisms, and it makes all of that a lot simpler. We flew our first one, our first kind of test one in 2021, and then our team have been developing more sophisticated versions since then. And all of that program is what's going to lead us up to these orbiters that we're going to send, hopefully, if we get funding in 3 or 4 years' time, to do that moon mission. But they will be CubeSats. So they're kind of built to do the job. Basically, you want to send them to a place where you really don't want to send a bigger, more expensive spacecraft. So for us, I feel are kind of really hitting that niche. You wouldn't want to put a big, expensive spacecraft like a couple of kilometers above the peaks on the moon, but much cheaper CubeSats. All right, maybe we'll risk that.
Gretchen, what are some of the most promising resources that could be mined from the moon, and how might these resources be used for future space exploration?
Excellent question. So one of the main things is when we think about resources here on Earth, we think a lot about, we need to find iron because we got to make steel so we can build things. We need to find rare earth elements because that's how we make our magnets now. It's how all of our nice little batteries work. There's just a variety of different things that we can get from the different elements. As a first pass, resources in space are not going to be exactly like that. And so for the moon, one of the most exciting things is that the confirming the presence of water and finding that ice and that water is a huge kind of resource for the moon. It could be quite a lot of water. And the reason that water becomes a resource for space exploration is that water is composed of the 2 elements that make rocket fuel. So in effect, you have to take the water and break it into its 2 component parts, and then you have to put it back together, because when you put it back together and turn it into water, it causes massive explosions. And that's how rockets kind of work. This is a very simplified version of rocket science, because I'm not a rocket scientist. But that is one of the major kind of resources that will allow a much better expansion into space exploration, because the Earth is our home. It's great. It's fantastic. We have a huge amount of water here. It's great. Getting off the Earth is really expensive because you need a lot of it. Because the Earth is big, it has a gravitational pull that likes to hold on to things, which is why we don't go flying off into space. So getting off Earth and trying to get off Earth and out into the outer solar system is expensive, very costly. It takes a lot of, going around other planets to really whip your speed up. If we can kind of transfer that kind of infrastructure to the moon and use the fact that the moon has the resource there, we don't have to bring the water with us. It's like being in Antarctica. You don't need to bring your water. It's already there. Then you can launch much more easily from the moon, because the moon is tiny and its gravitational pull is 1/6 of ours. That means you can take the same size thing and launch it into the same kind of thing at much less cost. You don't need as much fuel to do it, because it doesn't require the same maths. If we can find these, and we know that there are areas on the moon where water and ice should exist. And so this is really what the Artemis program is helping us to figure out, is we're gonna find those areas, and we're gonna start to really do the reconnaissance, the prospecting, to use that resource, because it's a resource that could potentially be renewable because of, things constantly hitting the Earth, or, we don't know exactly what the system looks like if there's water in the planet that can actually keep coming out and turning into ice, because we don't have that information about the interior. So there's a lot that can happen there. And we also know that building it from the moon, we can then translate what we learned there to asteroids, which is where we will find more water, and to Mars, where we know there's water there at the poles for sure, and we're still trying to understand what the range of resources that might exist there. But just the understanding of the geology, the past geology of Mars and several of the other planets in our solar system is just really interesting and important, and will help us understand the Earth a little bit better as well.
We're just going to pause for a quick break. We'll be back to talk a bit more about lunar mining right after this message.
Do you want to expand your career prospects in science or engineering? A postgraduate course at Curtin University can help you gain advanced technical expertise, skills and knowledge. You might collaborate on real projects with partners including BHP, CSIRO and NASA, or work on high-impact research initiatives including the Binar Space Program and the Square Kilometre Array. Get started on your postgraduate journey today by visiting curtin.edu/postgrad.
Phil, just before the break, we were talking to Gretchen about some of the promising resources that could be mined on the moon. What is the potential for that space?
I think it's going to be really fascinating. It's a lot of this, there's a lot there that hasn't been characterized yet. We really don't have much of an idea of where resources are. There was several missions starting in kind of the 90s. Actually, this is kind of, it's one of those interesting stories about why basic research and planetary science is so important. A couple of teams, donkeys years ago, I think starting in the 60s and then another one in the 70s, predicted the presence of ice at the lunar poles. and kind of in permanently shadowed craters. So so that if you try and imagine, the moon actually doesn't have much of a tilt in its axis. So if you make a crater at the pole, part of it never sees sunlight, and over millions of years, hundreds of millions of years, folks predicted that you could build up ice there, and it actually turns out that that happened. So based on that prediction, NASA sent spacecraft to test that prediction, and it's because of that detection of ice, really, that the Artemis is able to look at the moon and think about strategic resources at the moon. And so that original prediction in like a couple of papers has led to, you know, $100 billion program. Yeah.
This one can go to either of you, but what are some of the ethical and environmental considerations associated with mining the moon, and how can we navigate those?
I think, I mean, for me, there's at least in my opinion, there's kind of a boundary there in terms of about the type of the resource, about the nature of the resource. So if it's ice and you get an ice out of one of these permanently shadowed craters, by the way, that's going to be really hard because they have the coldest measured temperatures in the solar system. So that's 30 Kelvin. And so you'll be... So
that's minus 200 and something Celsius.
Yeah. 240 feels like.
Roughly, yeah.
So when we get that wrong, that's going to look really bad.
No, yeah.
And you got to get, so you're trying to get that out in absolute darkness at minus 240 Celsius and getting up and down a 30-degree slope. So there has never been a robot that can do that. It's an incredibly hard engineering challenge. But if you think about it, all right, what you're actually doing is harvesting ice and then using that ice for, as Gretchen said, for rocket fuel. We've both been on trips to Antarctica. When you want a cup of tea in Antarctica, you go out of your tent and you knock a bit of ice off and you melt it, and then you make your tea. You don't take liquid water with you to Antarctica in order to do that. So for me, with ice, that feels a lot more like what we do in Antarctica, right?
It's a renewable resource.
Well, yes.
In Antarctica it is, but even if it isn't on the moon, it's like still not...
Yeah. You're kind of, you're basically cracking in, on the moon, you're getting hydrogen and oxygen out of that. In Antarctica, you're just melting it. That feels different to me than digging a hole and excavating ore and mining that. I think there are different ethical considerations in those two scenarios.
There are, but I also think that on the moon, at least at this point, and this is what we would also have to make sure of, is that there doesn't appear to be any kind of major biodiversity or any kind of biodiversity. So mining on the moon isn't going to affect that kind of a thing. So it's not going to increase, it's not going to cause issues for living environments. So that is one of the kind of pluses of mining off Earth, in that as long as we have very much established that the biodiversity system is nil, which is what it appears because there's no atmosphere, there's no plants, there's no, they tried to grow, what was it, the Japanese? The Chinese?
Oh, there was...
On one of the missions, they actually chucked some like yeast, or they chucked some seeds or something onto the lunar surface to try and grow.
I think it was one of the US landers, and then they went to that spot in an Apollo mission and they brought back like some of the material from the lander, and I think there was bacteria still on it.
But there's a recent one of the recent, yeah.
Oh, BioSentinel is Is
No. It was one. Literally one. It's one of the. It was. It might be the Japanese mission. I can't. It might be. I don't. It's something that not planted, but it was an interaction of some kind of bio and the moon. I'll look it up, and we can discuss it at length over dinner.
All right. Okay.
I would love to be a fly on the wall for that conversation. And for anyone who heard, any of the listeners who heard the sound of a pen lid open and close, that was because Gretchen was busily working out if that figure was correct. How close did we get to the temperature being accurate?
It's probably minus 243, so he estimated very well.
I think that's very much within the range.
That's totally cool.
This has been touched on, but Phil, I'd love to ask, how will the Artemis program lay the groundwork for planetary science and exploration of Mars and beyond? And how might the program shape the future of human civilization?
I think, yeah, and it, a lot of what Gretchen said there is what excites me about it as well. I think that if we could, as a species, people often talk about the moon as kind of a stepping stone to the rest of the solar system. I think it does that in two ways. It kind of, you can think of it as going back to the moon and learning how to maintain habitats there and use resources that we find there. It's kind of training wheels for the rest of the solar system to get to Mars. If something bad happens at the moon, you're like a week away from help. If something bad happens at Mars, you're like 9 months away from help. So that's bad.
At the closest point.
At the closest, that's right. But I think like Gretchen said, is if we can use resources at the moon, if we can get ice and turn that into water and turn that into rocket fuel, then it is so much easier to get anywhere else in the solar system. There was something crazy, like I think with Apollo, I've got this thing in my head, and this is almost certainly going to be wrong now, that it was like 2,000 tons to get 2 guys to the surface of the moon, and it was 20 tons of fuel to get them back. So obviously coming back, they're kind of falling down what we call Earth's gravity well, whereas to get them out, you're struggling up. But that gives you a sense of the difference in there. So if we can do that at the moon, and if we can basically make rocket fuel at the moon, then really the rest of the solar system opens up for human exploration. It'd just be incredible.
How excited are you about how significant WA's role is in this project, in this program?
It's amazing that we, Rose has gotten the Trailblazer, which is actually going to put something on the moon, and just having the capacity for WA people and engineers and science all working together to create that, and having that be a success is just going to be a building block for kind of increasing how WA in particular kind of becomes a really big part of the whole space, getting back to the moon and space industry kind of laying the groundwork kind of for that. So I'm very excited about all of that, because it means that people here are going to be much more excited about the moon. You can tell from my accent, I grew up in the US, and NASA very much owns the PR machine there. We grow up thinking, I am going to be an astronaut. I'm going to. And they show us all the launches that have occurred. It's amazing. So I want that, and I'm excited that that is what this is going to help for WA and for Australia all the way across.
I think, and I'm always impressed by the kind of commitment of our state government as well to it's the state is basically, they've supported us, and they're supporting AROSE in that part of the exploration program. And whereas, elsewhere in Australia, it's been kind of those, like federal government previously really didn't embrace the kind of the exploration and inspiration of space. Our state government does, and they really see, it's both what we can do in terms of remote operations, but it's also science and exploration. And it's just lovely to be in a place where you don't have to make the argument for why is space exciting, why is exploration exciting, why is science exciting. The state government gets it, and that's tremendous.
I think that's a huge part of the culture of WA because of the mining industry. It's all about exploration. And, a lot of people get into it for all kinds of reasons, but a huge part of it is that you get to go and kind of wander around the outback and see what you can find and then figure out how to work with it. And exploration is just a huge part of what humans do.
There's something I'd also love to touch on. There are some other milestones that the Artemis program is set to make, having the first woman and the first person of colour. How significant is that?
Through the roof significant. I mean, one of the things I think is so important, and especially in the last, I would say 10 years in particular, is we are starting to see that diversity in being shown. And that's why it's important. It's the WITWA, Women in Technology of WA, is a fantastic group. They have a campaign called "If you can see her, you can be her." That's true. If you can see that role model, then that opens up your ideas of what's available for you to do. You're not shut out. Because even if it's not a specific door that's been closed or anything, the fact that you never see someone in that kind of a role means that you don't even realize that it's a possibility. And so I am just literally over the moon about the fact that this is happening, and it's not a TV show, right? We show this stuff on TV shows all the time. I got to say, one of my role models was Sally Ride, right? And so she was like a first American woman in space. Oh my gosh, a woman can do this? Oh, that's so amazing. And just a fantastic kind of to see that change over time as well, and how that is viewed. That's been really exciting to see. Really, really exciting.
When we're talking about excitement, a lot of one thing that a lot of people get excited about when it comes to space is a lunar eclipse. So we've got one coming up on April 20. Will you be watching it? Will you be travelling to check it out? Your thoughts?
They are incredible events, and I think anyone who hasn't seen a total solar eclipse should go and see it. It's it's like nothing else you've ever seen. It's not, it's as the moon goes in front of the sun and you get complete totality, and all of a sudden it's really quite dark and cold and in daytime, and it just feels weird. I mean, it's really kind of, I can't remember, there's a word for it, and I can't remember what it is, but it's something that is primal. It's basically, you're kind of a ape in East Africa, and you're not using your brain, you're not using your intellect. It just feels odd. It's great.
Unfortunately, we did not actually plan ahead well, so we won't be able to go up to Exmouth and watch, but we'll be able to see or be able to participate in the partial eclipse that we'll be able to see here from Perth. But I would say that if people have a chance, and if there's anything happening, it's a good idea to try and see it. But also, it's a very good idea to remember not to look directly at the sun. That's safety first. There are going to be some interesting, there are telescopes, and there will be these telescopes available, I'm sure, up there that allow you to look at the sun while it's happening, which is kind of an amazing thing. And we have, someone is coming in to visit us who's also going to go do that and bring his telescope.
Special telescopes, not telescopes.
Special telescopes.
Yes.
They are very...
Don't use a regular telescope. Don't use binoculars.
Don't use your own stuff. Go find the expert who has the stuff.
Yes.
And so I think that is going to be really exciting. And I'm excited that it's happening here and that there are so many people that are going because we are unable to actually get accommodation because we waited too long.
And just circling back to the Artemis program, if people do want to stay across it, what would be some of the best avenues to do that? How could they?
I mean, so NASA's been really great about kind of, obviously, you know, they've got an incredible PR machine and keeping people up to date. I think if you look on, you know, NASA will be making announcements both about their own missions and then also all the commercial lunar, it's called Commercial Lunar Payload Service program, and so there's loads of those missions by companies that are going to be sending landers carrying other people's payloads. They're going to be happening, I think the first ones are going this year, and so those are going to be on NASA TV. And a lot of those landers are going to be carrying amazing cameras. So the kind of stuff that we've not really seen before in you know, lunar lander missions with Apollo, it's going to be incredible. So I think NASA's going to be giving people a heads up about all of that.
And I think the Australian Space Agency also has information. So basically looking online and putting in NASA and Artemis or ESA and Artemis is a really good way to get the latest information. And I'm sure there are things that you can subscribe to that will ring your phone every time there is a new announcement.
Thank you, Gretchen and Phil, for coming in today and sharing your knowledge and obvious passion for space science and the new frontier that it's entering.
Happy to be here, and thank you for chatting with us about it.
You've been listening to The Future Of, a podcast powered by Curtin University. As always, if you've enjoyed this episode, please share it. And don't forget to subscribe to The Future Of on your favourite podcast app. Bye for now.